Part 1. The Hook. When reality stops making sense. There was a time when scientists believed the universe followed clear, predictable rules. Equations explained motion, gravity shaped galaxies, and light behaved in ways we could measure with precision. For centuries, physics has been our most reliable tool for understanding reality itself. But what happens when reality begins to drift away from those rules? Right now, across the universe, new discoveries are emerging that don't just challenge our understanding, they seem to contradict it. Observations that shouldn't be possible are being recorded. Patterns that should remain constant are changing, and forces we thought we understood are behaving in ways that defy explanation. These are not small errors or simple anomalies. They are signals, hints that something deeper may be at play, something hidden beneath the surface of everything we know. From deep space missions pushing the limits of human exploration to distant worlds that exist where they shouldn't, the universe is starting to look less like a predictable system and more like a mystery still waiting to be solved. And the question now is no longer just, what do we know? It's becoming something far more unsettling. What if the universe is far stranger than the laws we've built to explain it? Part 2. Humanity pushes outward. Artemis Il. As humanity prepares to step back into deep space, missions like Artemis II represent more than exploration. They represent exposure. Exposure to environments where Earth's protective systems no longer apply. Beyond our planet, the conditions of space become far more extreme and far less forgiving. Radiation levels increase dramatically. Gravitational influences shift as spacecraft move between celestial bodies. Even time itself behaves differently under these conditions, affected by speed and gravity in subtle but measurable ways. These missions allow scientists to observe how physical laws operate outside Earth's relatively stable environment. And what they are beginning to notice is that things don't always behave exactly as expected. Small irregularities, slight deviations, tiny inconsistencies that don't immediately break physics, but slowly begin to stretch it. It's in these moments at the edge of human exploration where the familiar starts to fade and the unknown begins to take over. Because the farther we go, the more we realize that Earth may not be the standard. It may be the exception. Part 3. Worlds that should not be there. In distant star systems, astronomers have discovered planets that seem to ignore the very rules that were used to predict their existence. These are not just unusual planets, they are contradictions. Some of these worlds orbit extremely close to their stars, in regions so hot and unstable that planetary formation should be impossible. Others are so massive that according to current models they should have collapsed into stars themselves. And yet they remain stable, existing in defiance of expectation. There are planets with densities that don't match their size, planets with atmospheres that shouldn't survive, entire systems that appear chaotic, yet somehow remain intact over long periods of time. Each discovery forces scientists to revisit the equations used to describe how planets form and evolve. Are these just rare exceptions, or evidence that the rules we rely on are incomplete? Because if planets can form under conditions we thought were impossible, then perhaps the universe is capable of far more than we've ever imagined. Part 4. Light under pressure. When a constant starts to shift. Light has always been one of the most dependable elements in physics. It travels at a constant speed in a vacuum, forming the basis of everything from relativity to modern technology. It is in many ways the backbone of how we measure reality. But in the most extreme regions of the universe, near massive galaxies, black holes, and powerful gravitational fields, light begins to behave in ways that are difficult to fully explain. Scientists have observed light bending more than expected, arriving slightly later than predicted, or showing distortions that don't align perfectly with current models. While some of this can be explained by gravitational lensing, certain observations go beyond what existing theories can comfortably account for. These inconsistencies are subtle, but they matter. Because when something as fundamental as light begins to show unpredictable behavior, it raises serious questions about the limits of our understanding. If the universe can alter the behavior of light under extreme conditions, then what else might it be capable of changing? Part 5. The strange case of a changing universe. The expansion of the universe is one of the most important discoveries in modern science. For years it has been understood that this expansion is driven by a mysterious force known as dark energy. For a long time, scientists believed this force was constant, a steady push causing galaxies to move apart at an increasing rate. But recent observations suggest something far more complicated. Measurements of cosmic expansion don't always agree. In fact, different methods of measuring the universe's growth are producing slightly different results. This discrepancy, often referred to as a tension in the data, suggests that something might be missing from our understanding. Some scientists now believe that dark energy may not be constant after all. It might change over time, evolve or interact with other forces in ways we haven't yet discovered. If that's true, it could completely reshape our understanding of the universe's past and its future. Because if the force controlling expansion isn't stable, then the fate of the universe may not be predictable either. Part 6. When particles don't follow the rules. At the smallest scales, physics is governed by quantum mechanics, a system of rules that has been tested and confirmed countless times. But even here, in one of the most precise areas of science, cracks are beginning to appear. Certain particle experiments have revealed results that don't fully align with theoretical predictions. Tiny differences in how particles decay, interact, or move through space are being detected. These differences are incredibly small, almost invisible, but they are consistent enough to raise questions. In physics, small anomalies often lead to big discoveries. These unexpected results could point to the existence of new particles, unknown forces, or hidden dimensions that we have not yet detected. It suggests that the universe may operate on a deeper level than the one we currently understand. A level where the rules are more complex and perhaps even more surprising. Part 7. Black holes breaking the limits of gravity. Black holes have always been at the edge of our understanding, places where gravity becomes so intense that space and time themselves are distorted. But recent observations are pushing even these extreme objects beyond expectation. Some black holes appear to have formed far earlier than they should have, given the age of the universe at the time. Others seem to grow at rates that are difficult to explain, using standard models of matter accumulation. There are also observations of powerful energy jets being released, with intensities that challenge current theories. Each of these findings suggests that black holes may not fully obey the rules we think they do. Or perhaps those rules are only part of a much larger system we have yet to uncover. If black holes are not behaving as expected, then our understanding of gravity, one of the most fundamental forces in the universe, may need to be reconsidered. Part 8. Signals from the unknown. Across the cosmos, scientists have detected brief, intense bursts of energy that appear without warning and disappear just as quickly. These signals are powerful, yet unpredictable. They don't follow clear patterns. They don't come from easily identifiable sources. And despite years of observation, their exact origin remains uncertain. What makes these signals so fascinating is not just their intensity, but their mystery. They represent events that don't fit neatly into existing categories. Each detection adds another piece to a puzzle that has yet to be solved. And until we understand what's causing them, they remain one of the clearest reminders that the universe still holds secrets far beyond our current knowledge. Part 9. Rewriting the rules of reality. When viewed together, these discoveries form a pattern, not of answers, but of questions. Each one challenges a different part of physics: gravity, light, particles, cosmic expansion. Individually, they might be explained, but collectively they suggest something deeper, that the framework we use to understand reality may not be complete. This doesn't mean physics is failing. It means it is evolving. Throughout history, every major scientific breakthrough began with anomalies, small observations that didn't fit existing theories. Over time, those anomalies led to entirely new ways of understanding the universe. We may be at the beginning of another such shift, a moment where the limits of our knowledge are being pushed, and new ideas are waiting to emerge. Part 10. Conclusion. The mystery continues. The universe has always been a place of wonder, but now it is becoming something even more profound, a place of unanswered questions. Every new discovery brings us closer to understanding reality, yet at the same time, it reveals how much we still don't know. What once seemed impossible is now being observed. What once seemed certain is now being questioned. And that may be the most exciting part of all, because the more we explore, the more we realize that the universe is not just complex, it is endlessly surprising. And somewhere out there, beyond everything we've discovered so far, the answers are still waiting. Don't forget to subscribe, like, comment, and share. Thank you for your time.